Hello, math students. We're going to spend another day working with solving systems of equations by elimination. The first lesson that we did on this, I said, hey, you don't have to worry about step one. I'll take care of that for you today. Now, I'm not going to do that for you. So what we have to do today as our first step is make sure that we've got one of the variables have opposite coefficients. So when we add them together, they'll be eliminated. They'll go away. That's why we call this elimination. So that's the one step that we have to add. You've already done these other steps. So let's go ahead and get into one of these problems so we can try it out. In this problem, I want to solve the system by elimination. I want you to notice if I would just add these two equations together, by the way, don't write this down because this is going to be totally wrong. If I would just add these two equations together exactly the way they are, negative 6x plus negative 2x is going to be negative 8x, positive 5y and negative 4y, well, that's going to be plus 1y equals 25 plus 14 is going to be 39. Some students want to do that automatically because that's what we were doing in the last lesson. However, nothing was eliminated. Nothing goes away when I add these two equations together. What I need is to get either the x's or the y's to be opposites. Now, this is the fun part of these problems, in my opinion. I want to get the smallest number possible that I can make. For instance, if I was going with the x's or with the y's, the smallest number that they could both change into. Now, I'm going to pick the x's, and I'll show you why in a second, but I'll talk about the y's first. If you looked at this and you said, hey, I want to make these y's be opposite, I want you to think about the smallest number that 4 and 5 can both go into, that they're factors of, so it'll be a multiple of those. And the smallest number they both go into is 20. If you were saying 1, you were thinking about factors, you were thinking about dividing, but 20 is the smallest number that they're both going to go into as multiples. That would mean that I have to change both equations to make them into 20s, one to be a positive 20 and one to be a negative 20. So that's possible, but we're not going to really be doing problems that are that difficult today. What I want to look at now is these x's. The top equation has a negative 6x, like that. If I could make the bottom equation have a positive 6x, they'd be opposites. That's what I want. So I want to make that negative 2x turn into a positive 6x. So I have to think about what I'm going to multiply by to make that happen. If I would multiply this equation by negative 3, that's going to do the trick for my x's. So let me write down what I have right now. My first equation doesn't change. Negative 6x plus 5y equals 25. The second equation, I'm going to have to distribute. Negative 3 times a negative 2x is positive 6x. That's what I wanted. Negative 3 times a negative 4y is going to be a positive 12y. And then here's the step that a lot of people forget about. I also have to multiply it after the equal sign. We've never done a distribution like that before, but we can do this. We know it's going to be a negative, and 14 times 3 should be 42. Now I can add my two equations together. The x is gone. That's what we were hoping for. 5y and 12y gives me 17y. Positive 25 and negative 42, that should be negative 17. So we can solve this. The y is negative 1. Now I just have to go back and find the x. Now I can use my changed equation that I have, or I can use one of my original equations. Doesn't matter at all. It won't give you any different answer because this will be the solution no matter which equation or which version of the equation we're using. So if the y is negative 1, I'm actually going to just use this equation that we changed right here. That's the one I'm going to use. So I had negative 2x plus negative 4 times the y was really a negative 1 equals 14. Negative 4 times negative 1 is positive 4. And now I would get rid of that 4, and divide. So the x is -5. Now my ordered pair, every time x and then y, I'm going to get -5, -1. And if you wanted to check it, you could substitute it into any of the equations. If I would check this with the top equation, let me see, what color can I use there? -6 times a -5 for the x would be +30. 5 times a -1 would be -5, and 30 plus a -5, all that does equal 25. It works in that top equation. I feel like I skipped a slide, I guess not. Okay. I did skip a slide. I missed these first ones. In these first problems, I want you to notice that they look quite similar to our last lesson. In this problem, I can see that the 6y's are exactly the same. The only thing that I have to change is I don't want both of them to be positive 6x or 6y's. I need one of them to be a -6y. I'm going to distribute a -1, which really just changes all of the signs. I'm going to show it to you as a distribution, and then I'll show you a different way to look at it also. So I'm going to distribute a -1. So that did not change my top equation at all. Let me rewrite that one. When I distribute this, I'll get a -4x and a -6y, and now that's going to be a positive 28. So my y is positive 6y, -6y gone. 10x minus 4x or plus a -4x is going to be 6x equals 48. So the x is going to be 8. Now I have to go back and find the y. In any of the equations, let's just use the top equation, I guess. So I would have, from this equation right here, 10 times 8 plus 6y equals 20. That's 80. And we'll subtract the 80. So I can get that 6y equals -60. And then the y is -10. So my ordered pair is going to be 8, -10. Here's the other option that you have. Instead of distributing a -1 and taking a step to rewrite that, this is what I usually do. I would usually just say, I'm going to multiply that second equation by -1, which just changes every single sign. That would be a -4x, a -6y, and a positive 28, which you can see is what I had right there. So I tend to just change signs, but you can certainly go ahead and show that distribution if you'd like. In this problem, this time the x's are exactly the same. They're both a -3x. And I really want one of them to be a positive 3x. So I have to multiply one of these two equations by a -1. I'm going to do that changing sign thing. And I would probably pick the bottom equation. I'm going to multiply the bottom equation by -1, which will change this to a positive, and a negative. So when I add these, my x's cancel. A -1y plus 4y is going to be 3y, and 21 minus 3 is going to be 18. So the y is 6. Once I know what the y is, I can go back to my original equations, or I can go to the changed equation. To be honest, I kind of like the equation that I changed, because now that's a positive 3x plus 4 times, here's my y, equals -3. So I would subtract the 24. 3x equals -27, and then divide. And I would get that x is -9. So ordered pair, X and then Y. -9 and 6. So sorry that the slide order was messed up a little bit there. These were multiplying by -1. This problem that we did, we had to multiply by another number. And now let's try this out. In number 4, I can either get the X's or the Y's. It does not matter. If I go for the X's, I hope that you can see that 6 would be a really nice number to use. I could make this into a -6 if I multiplied by -2. On the other hand, if I looked at my Y's, this is a positive 3Y. If I could make this a -3Y, just by multiplying by -3, that would work as well. And it really doesn't matter. You can truly pick either one. I guess I'm probably going to pick the -2, just because multiplying by -2 keeps my numbers a little bit smaller. So if I multiply this equation by -2, I'm going to distribute. I can just rewrite that equation. I'm just going to pull it down underneath this one. They'll still be right next to each other that way. So that'll be a -6x, a -2y, and -22. When I add those together, the x's are gone. 3y minus 2y is just a 1y or y, and 24 minus 22 is 2. So there's my y. Now I need the x. I'm going to use this top equation exactly the way it is when I started. So 3x plus, instead of y, I'm going to put a 2 in there. So we'll get rid of our 2. And then divide by 3. So my ordered pair, x and then y, 3, 2. On this problem, if I try to get the y's to be opposites, multiplying by a whole number, I can't make that -2y into a positive 5y unless I multiply by a fraction. I'd rather not do that. I could change both of the y's to be 10s, but again, I'm not trying to do that today either. Let's take a look at the x's instead. If the top equation has a positive 4x, I could make this x into a -4x. And it's already negative, so I only have to multiply by 4. So that'll distribute. Now, I do like my two equations to be right next to each other, so I'm going to rewrite the top equation. I didn't have to do that in the last problem because I just took my bottom equation and kind of made it into a top equation. 4 times a -x is a -4x. 4 times a -2y, or subtracting 2y, would be a -8y. And 4 times 8 is going to be 32. When I add these two together, gone. -5y, -8y is -13y. And 32, or -19 plus 32. Let's see, that would be 13, positive. So the y is -1. Now that I know the y, I still have to find the x. I don't care which equation you use. I tend to not use the ones that have negatives in them. However, that second equation is kind of nice. I'm going to use the second equation. I'm going to say -x, or -1x, minus 2, and then here's my y, equals 8. So to solve this, I would get rid of my 2, move that over, and I have -1x equals 6, and divide. X is -6. So my ordered pair, x and then y, I'm going to get -6, -1. In this last problem, you're going to notice it doesn't look like the rest of them. All my other problems have the x and the y together. This one doesn't, but both of the y's are lined up and the equal signs are lined up. The x's aren't, and the regular numbers aren't. So I would want to rearrange this a little bit. On that top equation, I would probably just flip-flop these two things. And let me rewrite that right here. 5y equals negative 5x plus 15. Now that I have that, everything's lined up. Now look at my y's. That new equation I just wrote had a positive 5y. If I could make this one into a negative 5y, I would have my opposites. That's what I need. So I'm going to multiply this equation by negative 5. That'd give me a negative 5y, positive 10x, and negative 15. So those will go away. I do need something there. It's got to be a 0. Negative 5x, positive 10x, that's 5x. Negative 15 plus a negative 15 is 0. That goes away. Well, this is kind of nice now. X is just 0. If the x is 0, I can go back and find the y. I'm going to actually use that second equation. I just said y equals negative 2 times 0. Well, that's 0. Plus 3 is going to be 3. So the y is 3. My ordered pair is 0, 3. Here's our last problem. Our next lesson, we are going to be doing a whole lesson on story problems, but I thought we could get a little bit of a preview here. You purchase 5 pounds of apples and 2 pounds of oranges for $9. Your friend buys 5 pounds of apples and 6 pounds of oranges for $17. I want to write an equation to represent this, and then we want to figure out how much the apples are and how much the oranges are. So for my equation, instead of x's and y's, let's pick letters that make sense. I'm going to use an A for apples. However, I'm not going to use an O for oranges. It looks like a 0. We're not doing that. Let's use maybe the R, I guess. So I have 5 pounds of apples and 2 pounds of oranges, and my total was $9. My friend also got 5 pounds of apples, but they got 6 pounds of oranges. Right now, I can see that my A's are exactly the same. If I could make one of those turn into a negative 5A, we'd be ready to do this. So let's multiply the top equation by negative 1. Negative, negative, negative. The A's would go away. This would give me 4R equals 8. So R is 2. So that really answers the last question. What's the price of a pound of oranges? That's $2 per pound. LB is the abbreviation for pound. The price for apples, I'm going to have to go back into one of those equations to figure it out. Let's use that first equation that didn't get changed, before it got changed, I should say. 5A plus 2 times, well, the oranges were $2, we said, equals 9. So let's get rid of our 4. 5A equals 5. I really wish this was real, because if apples were only $1 per pound and oranges were only $2 per pound, that would be really nice. So your worksheet today, solving systems of equations by elimination. It's the day 2 worksheet because we are going to have to do some multiplication. There's an answer key and Schoology. There's a learning check for you to do when you're done. Let me know if you need any help.